These past few months, I have been spending a lot of time in the shop, and I have gotten a lot of work done, either on or for my machines, mostly. Fixing, cleaning, making tools, etc. However, the entire time, there has always been this one thing that I've been avoiding. The proverbial elephant in the room, if you will. Always looming in the background and breathing over my shoulder. Today, I think it's far past time that we address it. It's time that we talk about my milling machine. Welcome back. This is my milling machine, or more accurately, this is the head of my milling machine. I am in fact standing on a ladder and you are standing on a tripod. I hope you're not afraid of heights. As is clearly indicated by the writing on the machine, this is a Bridgeport Series 1 Variable Speed J-head. However, in spite of the writing on this faceplate, it is in fact a 1.5 horsepower machine, not a 2 horsepower. But that's besides the point and isn't really what I brought you up here to talk about. What we need to talk about is maintenance. This machine is pretty old, and I don't know if it has ever been maintained in its lifetime, but I do know that it hasn't been maintained anytime recently. I have been putting off this job for as long as I've owned this machine because honestly, this is not a can of worms that I am really looking forward to opening up. However, it has gotten to the point where it thumps, it shakes, it's loud, it's just not a pleasure to use, and it even affects the quality of the work that I can get out of the machine. Eagle-eyed viewers may even notice in some of my previous videos in the milling sections, if you look close, you can often see the camera shaking. That's the shake of the machine translating into the camera. I have wanted a Bridgeport for a long time, and the fact that I finally now have one and I don't want to use it because of how uncomfortable it is to use, well, that's a serious problem to me, and it is high time that we solved it. I think the first thing that I would like to do is to try and give you a little bit of a better look at the problem. I don't know how well it's going to come through on the video, but hopefully this will give you a little better insight into exactly what it is that we're trying to fix here. Also, if anybody else is experiencing something similar with their mill, hopefully, if all of this goes well and fixes the problem for me, maybe it'll give you some ideas as to what you can do to fix it for yourself. This is the speed control on a variable speed Bridgeport. When the motor is running, you can spin this in either direction, and that will allow you to cycle through these infinitely variable speed ranges in either the high or low range of speeds. This lever here on the side of the machine is what you would use to select either your high or low range of speeds. This basically engages a back gear. The way that this machine creates that variable speed functionality is through a mechanical system commonly referred to as a Reeves Drive. It works similar to something like a snowmobile if you're familiar with those at all. Essentially, there is what's referred to as a pancake pulley attached to the spindle and an opposite attached to the motor. So when you turn this dial in either direction, it will cause that pancake pulley to either expand or contract, thereby making the diameter of that pulley either larger or smaller. The one in the back reacts in the opposite direction. So for example, if you're spinning this up into a higher speed range, the pancake pulley in the front is expanding, allowing the belt to slip further into it, effectively creating a smaller diameter pulley in the front, which allows the pulley in the back to contract, thereby creating a larger pulley in the back. So as the pulley in the back gets larger and the one in the front gets smaller, the spindle spins faster. If you've never actually seen one of these before, I'm sure that it's kind of hard to imagine, and we'll get a better look at it once we get this thing opened up. So why am I explaining all this? I'm explaining it because what I think is happening in my case is that the belt that rides on those pulleys is worn. So as I traverse through these speed ranges, it causes that belt to loosen up or ride kind of wobbly, which is causing all of that noise and vibration. So now I would like to try and demonstrate that for you. In just a second, I'm going to start the machine up. As you can see, we are currently sitting right around 2100 RPM. I'll start the machine. It'll spin up to that speed. I am then going to run it up to maybe around 3000 and then immediately start cranking it down to the bottom of this speed range. Hopefully, as we start to get to the bottom of this speed range, you will be able to hear that the machine is going to start shaking and thumping and just generally running a lot rougher. Okay, let's head over to the bench. So if you go poking around the internet, the forums, searching for information about troubleshooting noises in these variable speed heads, you will find that the list of possible parts, bearings, etc. that can become worn and need to be replaced will grow very, very long and very, very pricey very, very quick. That being said, there is a shorter list of sort of usual suspects that we can start with. First up, of course, is the belt, as we already discussed. I don't know if this is going to turn out to be the problem, but I am sure that that belt in there is worn. I am sure that it is at least contributing to the issue, and so I feel confident that replacing it is going to help. So we have the belt. Next, there is a whole range of bearings that could be replaced in that head. This is just really the easiest bearing to replace. This is the one that sits right above the drawbar, and I figure it's going to be really easy to get to it, so I'm just going to pop it out and replace it. We'll check some of the other bearings while we're in there, but we have this one so that we can at least replace that. The other thing that very commonly becomes worn in these machines is the plastic bushings that fit inside of those pancake pulleys. So those pulleys, as they expand and contract, one of them rides on a shaft up and down, and there's a plastic bushing inside of it that it rides on as it slides up and down that shaft. That bushing, being plastic, of course gets worn. We're going to check those when we get this thing pulled apart, and if they do feel like they need to be replaced, we have the bushings here to replace them. So that is it. That is our general plan of attack. Hopefully this doesn't spiral into a complete mess of a project, but let's head on over to the mill and start disassembling the head. The first thing that we want to do is run the machine down to its lowest speed. We have already done that, so we can move on to disconnecting the power. Next thing we want to do is remove this bottom motor cap. Next, we want to take two of those same screws that we just removed from that bottom motor cap and we want to thread them up into these holes under the spring that compresses our pancake pulley that's attached to our motor. What this is going to do is it should allow us to completely compress this spring. All right, I was able to get both of those threaded in there nice and tight. That spring now should be compressed, which is going to make our lives a little bit easier when it comes to getting the motor off. Now that we have the rear pulley fully compressed, we want to take this front pulley with the motor off and run it all the way up to the highest speed. So what we've just done is we've basically opened up the back and now the front pulley as much as possible. This is going to give us as much slack as we can get in that belt. So now, if you look in there, you should just be able to see the outside edge of that belt. See it moving there? So now we want to take a screwdriver, long stick, whatever we've got, and just push that belt back into that pulley as far as we can. Next up is our top bearing cap. That's this guy here. I'm sorry, I know you can't see it very well, but I've got you raised up as high as I can get you. It's just 3 socket head cap screws. And now we can use those same 3 screws we just pulled out. There's 3 threaded holes that allows us to use them as jack screws to get this thing popped loose. Wavy washer, and there is our top bearing cap. All right, so I've got you off the tripod so you can get a bit of a better look up here, and I can tell that someone has been in here in the past. These are marks from those jack screws, and as you can see, there are multiple sets of marks. So somebody has definitely been in here, and honestly, this bearing feels pretty good. Okay, so now that we have both of those pancake pulleys opened up as far as they'll go, and we've pushed all of the slack in the belt as far back as we can towards the motor shaft, we should be able to start working on getting this motor off. Step 1 is to take out these bolts. They are a 9/16, and there's one on each side. And so now, hopefully we can just sort of tilt this back without dropping it. Okay, get it free of that belt, and there we go. There's our motor. And so this is that pancake pulley, and you can see how it can either, probably not a good shot of it, but it can either compress or grow, allowing the belt to slip further in or get pushed further out, making it either effectively a bigger or smaller pulley. Okay, so I've got you off the tripod for a second so that I can give you a better shot of a couple of things happening up here. Basically, all that we have to do now is disconnect the few remaining fasteners that tie this top section of the belt housing to the bottom section. So you can see this seam here that runs across the entire length of this thing. That's the top section, and we're going to remove that entire top half. So we just have to disconnect a couple of things before we do that. 3 of those are right up here in the head. We have this snap ring right here. We're just going to pop that guy off. And then we have 1, and then there's another on the other side, 2 socket head cap screws. I just wanted to give you a better shot of that so you could see what I was doing when I was up here. And these set screws also have this little sleeve on them. So when you remove these, you want to be careful not to drop that down inside. Next, we'll disconnect our faceplate. We'll just leave this connected and hanging here. It's connected via this chain to the tilt plate up inside. And now we're ready to start removing our upper belt housing. And that's just 4 socket head cap screws up top here. And 1 around the back. This belt is not nearly as bad as I was expecting. It's certainly old, and you can see some cracking around the edges, and you know, just it's worn, but I was expecting worse. I don't know if that's a good thing or a bad thing. These bushings, on the other hand, these need to be replaced. You see all that play? That shouldn't be there. This should be a nice, tight sliding fit on this shaft. In fact, I should be able to move this to like any spot and it should just stay there. It should be tight enough that the friction will keep it in place. It should move up and down, but it should take a little bit of force to move it. But this is just really sloppy, so those bushings are shot. Also, you hear this? That bearing in there, that guy needs to be replaced as well. So we'll take care of that too. This bushing on the motor shaft is just as bad. There's all that slop. Here's a better look at that bushing. It's actually a split bushing. There's one on each side. I think you can kind of see the seam down the middle there. You can also see how thin it is for one, but you see how it's just kind of flopping around in there? It's supposed to be epoxied in place, but that epoxy, I guess, has just dried up and turned into nothing a long time ago. And so it's just kind of flopping around in there. I think I can just pull it. Yeah, I can just pull it right out of there. That's not supposed to happen. So yeah, we'll have to get these out. We'll also have to get this epoxy cleaned out from the inside of these bores on this one and the other one. But first, we'll need to get this bearing cap housing off. So let's do that. Okay, before we deal with these bushings, we want to get everything else stripped off of these pulleys. For this guy, that means getting this bearing assembly removed. And for this one, it means relieving the tension on this spring and getting the spring removed. We will tackle this guy first. And for that, we are just going to use these 2 pry bars, and hopefully this thing should pop right off. Well, that was actually pretty tough, but I think we survived, no worse for wear. So on to the next one. For this one, I just quickly threw together this little contraption here that should allow us to let off this spring pressure slowly and safely. And now we can just release this pressure. Okay, let's try this. I saw this going a lot smoother in my head. All right, so there's that bushing for this one. Houston, we have a problem. Well, I don't want to say problem. Let's just say an unfortunate and, in my opinion, ironic and unnecessary obstacle. This is the replacement bushing kit that I purchased for this project. These are the bushings that came in the kit. More specifically, this is the bushing for the front pulley. This is the bushing that I took out of the front pulley. As you can see, these two things are essentially the same. This one's old and worn, but you can tell they're the same part, and this will slot in where this came out. These are the bushings that are supposed to fit the rear pulley. They look just like these, only smaller. This is my rear pulley. This looks nothing like this and is obviously not going to work. Mind you, they're both just plastic. This is a thin little black piece of plastic, and this is a thick teal piece of plastic, but they're both plastic. So what's going on here? This is the little piece of paper that came with the bushing kit. I'll read to you from this piece of paper, and I quote, "If the motor vari-disc bushings are blue or teal in color, you will have to replace the entire motor vari-disc assembly." I'll read that again for effect. If the motor vari-disc bushings are blue or teal in color, you will have to replace the entire motor vari-disc assembly. So you're telling me that just because this piece of plastic is a slightly different shape and a slightly different color from this piece of plastic, that we somehow live in a world where this piece of plastic cannot be manufactured and changed, but this piece of plastic can, and as a consequence of that, I have to now replace a very expensive part as opposed to replacing a cheap and easy part. To make a long story short, I called H&W Machine Repair, and yes, that is exactly what they're telling us. So what are the options? Because surely there are options. Well, I think the most obvious option would be to remove this and then just machine a new one from something like Delrin, nylon, some material that's similar to what's in here now. Unfortunately, I don't have any material like that of this size in the shop, so I'd have to order it. Not a big deal, but it's going to take time. Option number 2, again, we remove this piece, then just machine out this inner bore to some nominal diameter, press in a piece of material, and then remachine an entirely new bore that would work with these bushings. Again, I don't think that this is a terrible idea. However, like the last one, it requires a lot of time, a lot of machining, and sort of back engineering the features and dimensions of that inner bore that would be required to work with these bushings. It's going to be a lot of work. So what are we going to do? Well, truth be told, I already bit the bullet and ordered the new vari-disc assembly from the machine repair shop. That's going to take a couple of days to get here. All of these extra parts, all of these unforeseen obstacles are already pushing this video back. So really, it's a race against the clock. I have to get this project finished so that I can get this video edited and published so that you can watch it. So with that in mind, I guess let's get to work on all of the other things that we have to work on. Which brings us back to our front pulley. Before we can epoxy in our new bushings, we first have to remove all of this old epoxy from inside the bore. For that, we're going to use our Dremel. All right, I think that should be cleaned out good enough. You can see that I do still have a little bit left in the key slot here, but I got the bulk of it and I think that should work. The bushing repair kit comes with this gauge pin. It's just a hardened pin that is the same diameter as the shaft that this is going to ride on. And we can use this to check the general fit of our bushings. So before we put the glue in, we can put the bushings into our part, and we should be able to push this through by hand, which we can. And that means that we got all of the old glue out and we are good to go and ready to start gluing all this together. Step one, we need to mix up our epoxy. This is a 2-part epoxy. Get all that squeezed out and just mix it all together. The instructions say that you have 3 to 5 minutes working time on this stuff. And we'll take a bunch of it and just slather it onto the inside. Then we'll take our bushings. We want to squeeze them together and then just drop them into place. Make sure that our keyways line up. Do the same thing with the other side. Then we want to take our gauge pin. We're going to coat this with WD-40. That way the epoxy doesn't stick to it, and we want to push it straight through. And it's a tight fit, I'll tell you that. You can see that it's squeezing the epoxy out. Using the gauge pin like this is going to make sure that as this epoxy cures, the bore that we're creating with these bushings stays the size that it should be, and that it's going to fit on our shaft when all is said and done. Now we just let this dry. Next up, we have a couple of bearings to replace. As I mentioned previously, you could go a lot deeper into this head, and there are plenty of additional bearings that you could and arguably should replace while you're in there. I, however, am limited by both time, I need to get this video edited and uploaded, and budget. These parts can get pricey. So this is what we're doing for me, but if you were to choose to do this for yourself, there is more that could be done. That being said, these are our 2 bearings. We have one that we'll be replacing in this cap here. There's a wavy washer underneath of this one. And then this one, we just need to press this bearing out and then press this one back in. When I disassembled this one, there was grease in this underside here and all over this wavy washer. So I will be replacing that. For that, I'm just going to be using Lubriplate. This is just the general purpose grease that's recommended for the Bridgeport. So this is what I'll be using. So as it turns out, this rear pulley is pretty much exactly the right size to press this bearing out. Don't judge me. We're not going to use it anyway. We're replacing it. And I mean, look, it's almost perfect. Look at this. Huh? We're going with it. See? Worked like a charm. And now we just need to press the new one in. I did put a little bit of grease in there just for good measure. All right, I guess that looks pretty good. The epoxy should now be dry on our bushing, so we just need to knock this sizing pin out. And once that's done, we can then press the entire bearing assembly back onto the pulley shaft. All right, now we just need to head over to the press and well, that pretty much wraps it up for the repairs that we need to do. This sounds much better now. It's nice and smooth and quiet. And our replacement pulley did arrive in the mail today. As you can see, it does come with an entirely new spring assembly. The bushings are already pre-installed along with the key, and this whole assembly just replaces the old one entirely. So I guess all that's left to do now is to put it all back together and then give it a test run to find out whether or not all of this work has made any difference. Well, here it is. It's all back together. I guess now we get to start it up and find out if our work made any difference. As far as I understand it, the first time that you start it up after doing something like this, you're supposed to leave those screws loose that hold the housing together. That way, as the machine starts running, it will sort of, I guess, shift around and balance itself and just kind of find its own natural resting place. And then as the machine continues to run, you'll start tightening down those screws. So that's what I intend to do. I don't know if that's going to cause any vibrations or rattling in the very beginning as it shifts around, but hopefully as we tighten up those screws, we'll begin to get a nice, quiet, smooth running machine. So without further ado, let's start it up and see what we got. Okay, I've got you pointed at the faceplate so that you can see the speeds as we run through them, and hopefully you'll be able to hear if there's any difference between the sound of the machine now as opposed to the sound from the beginning of the video. I'll be standing right next to you on a ladder ready to start tightening down these screws, and yeah, I guess that's it. So here goes nothing. And here it is running with the housing tightened down. I really hope that you can hear that difference. Wow, I really hope that you were able to hear that difference. Absolutely night and day. It is smooth and quiet. It sounds and feels like a completely different machine. I guess I really didn't know what to expect, but the difference between the machine before and after doing this maintenance absolutely blows away any expectations that I might have had. So I guess here's the obvious question. If you have a Bridgeport or any one of the numerous clones that uses the same or similar drive system, would I recommend doing this maintenance? Yes. If your machine is running rough, if it's loud, if it's just not a pleasure to use, it is going to completely change what it feels like to be in the shop when that machine is running. So I guess that about wraps it up for this one. If you've made it this far into the video, thank you. The support that you have shown and continue to show to the channel, it is motivating, it is inspiring, and it is humbling. So thank you. Our subscriber count continues to grow far beyond anything that I ever imagined was possible. So to those of you who have subscribed, I appreciate you and thank you again. If you haven't subscribed and you like what I do here and feel like I've earned it, give me a like and a subscribe. If you feel like I haven't, let me know what I can do better in the comments down below. And as always, until next time, get out there, make something awesome. Most importantly, have some fun. And I hope to see you all again very, very soon.